Hi, everyone, and thanks for coming to our first introductory workshop for the Sydney GPU cluster. I'd like to start off by recognising and paying respect to the elders and communities past, present and emerging of the lands the University of Sydney's campuses stand on. For thousands of years, they have shared and exchanged knowledges across innumerable generations for the benefit of all.
Screen share.
Oh, sorry. I'm not sharing my screen for the Zoom. Bear with me for a second. My slides in the Zoom? Yes. Okay. Okay, thank you for helping me out there. Thanks. So I'm Mike Lynch, and I'm the group lead for software engineering and research compute here at Sydney Informatics Hub. And with me in the room are Tim White, Shang-Jin Fan, and Tom Mouch, who are the research computing team and software engineering team. And on Zoom is Jinwei Law, who's another member of our team. I'm going to start off with an overview of the cluster, talking about what it is, how it's different from a classical HPC environment. I'll talk about some of the specific terminology we'll be using in the workshop, how the cluster is integrated with other systems at the university. I'll also talk about what status the system is in now, and about our pricing and support model. I'll then hand over to Xiaojin, who will take us through how to log into Run AI. Run AI is the web interface to the cluster, and he'll also take us through how to start a workload. We'll then have a short break for morning tea. After morning tea, Tom will take us through how to transfer data to and from the cluster's Scratch storage, and he'll then give us a demo of how you can start and interact with workloads using Run AI's command line interface. And we'll then wrap up with a quick Q&A session. So about the cluster is 3 NVIDIA DGX nodes, and each node has 8 H200 GPUs. It's also got about 7 servers alongside it that provide the orchestration system. They host the web front end, and it has a petabyte of fast storage as Scratch. The software stack is all provided by NVIDIA. So the user-facing part is called Run AI, and that's mostly what we'll be interacting with in the workshop today. Underneath Run AI is an orchestration service, which is engineered, excuse me, to get the maximum utilization out of data center grade GPUs. This slide is just an overview, excuse me, an overview of the 4 different ways we're going to make the cluster available to research users. So the first of these, raw GPU access, is what we're covering in today's workshop. We're also going to be setting up standard workflows and pipelines in specific domains. There's a lot of interest in things like AlphaFold for computational chemistry, and our bioinformatics team are kind of keen to get their next flow stuff working on it. But there's all sorts of domains where we could run specialists, basically take workflows, package them up and make them available to researchers so they don't have to do the setup themselves. The final 2 ways of working with the cluster will be through web interfaces, and these are using the cluster as a backend for AI applications. So the first of these will be an open weights large language model, and we'll also be deploying an interface called Label Studio for image segmentation and labeling images and text. And these are things that are probably going to be coming in 2026. So I'm recycling this slide from a conference I went to in Brisbane last week, and I was part of a panel talking about the challenges which we face supporting scientific computing for research. So in traditional HPC, you can run containers if your platform supports it and if you really want to, but you usually don't have to. You can generally SSH in and just work as if you were on a Linux system. In particular domains, like especially in bioinformatics, there's been a lot of work building workflows using technology like Nextflow, and these mean that there's been more uptake of containers in these disciplines. But the GPU cluster is a modern ML and AI environment. The marketing people at NVIDIA call it an AI factory, although it obviously has applications beyond just AI, and containers are mandatory. So if you want to use it, your compute workload has to be in a container. That's sort of the cost of entry. The grey bit below with the highlighted text, this is from the documentation of Run AI. And when I was reading it early this year, it just jumped out at me that it said researchers are typically proficient in working with Docker. So just to get a feel for the room, can you raise your hands if you've heard of Docker? Can you raise your hands if you've used it? Oh, that's good. That's good. Pardon? Online. How many people online? Have we got?
Something proficient though.
Yeah, but are you proficient? Yeah, exactly. So the reason why I wanted to bring this up last week at the conference is that we don't want learning Docker to be one more thing which you have to do to be able to use the cluster. I was expecting a high rate of Docker here, but it's good to see. Luckily, there are ways in which we can use containerization to reduce the burden on users, on research users, and I'll talk more about that in a moment. But I think the reason for this phrasing in the documentation is that the documentation is very much aimed at corporate customers. And if you read through the documentation more, you can see when they're talking about a researcher, they're talking about a data scientist who's working for a corporate and who is proficient in modern DevOps because that's what you have to do to be a data scientist these days. Even though the DGX is on-prem in a sense, so it's in the university's data center at Eastern Creek. It's next door to the data center that the research data, or the main copy of the research data store is in. Working in it feels a lot more like cloud computing than traditional HPC does. So this slide is basically just an overview of what a workload is on the cluster. The basic unit, a workload, it corresponds to what you might call a job in traditional HPC. And this diagram shows the bits and pieces which a workload needs in order to be useful, because in isolation, all it can do is make the GPUs get hot. A workload belongs to a project, and projects are the basic way in which the cluster controls who can see and who can do what. So your project will have the members of your research team, and it's also how we're measuring usage and we'll be doing billing. A workload typically has a data source, which is a way of connecting it to storage. This is so that it can read in data and write out results to something that will persist for beyond the life of the workload. So as I said, there's a petabyte of storage attached to the cluster. It's got various technical wizardry set up so that you can get data very quickly from the storage to the GPU, bypassing the CPU. But we're trying to encourage people to think of it as scratch storage. A petabyte will fill up very quickly if people leave their data lying around on it. It's not designed for long-term data storage. That's what RDS is for. And later in the workshop, we'll be covering how to get data to and from RDS. A workload also can have one or more interfaces to the outside world. Run AI calls these tools, which I find unfortunate and confusing, but we're stuck with it. For example, the workloads we will be demoing this morning, their interface is a Jupyter notebook. So you can connect to it with a web browser and interact with it the same way you'd work with a Jupyter notebook on your laptop or something like Google Colab. Our workload can have other interfaces than Jupyter. It can also not have interfaces. It could just be a process that loads data from its storage, does some compute on the GPU, and then writes it back again. And lastly, a workload needs an image or a container. So this is something on a registry somewhere, like on Docker Hub. NVIDIA have their own container registry. And that is the container that packages up all of the actual software that you need to run, and its dependencies and so forth. So there are a lot of things to configure to get all of this working, and we're automating as much of this as possible of the setup. So ideally, we don't want our users to have to put all these things together manually. I'm just stepping through it really explicitly so that you can get a mental model of what a compute workload on the cluster involves, and also just to introduce some of the terminology which the Run AI interface uses. For this workshop, we'll be using containers which SIH have pre-built. All we need to do is provide the name of the image in a registry, and Run AI will download it and try to start it. So this is one of the ways in which we're hoping to be able to use containerization to streamline things for researchers. It gives us the ability to provide a base image which has commonly used libraries like TensorFlow and PyTorch, which are working against the right version of CUDA so that we know that they will work on the cluster. It means that if we can do this and we can be assured that they work, it means that researchers don't have to wrestle with the dependency management problem. And if researchers need a particular specialized dependency on top of these, then we can use these base images that we provide can be used as a starting point to build further containers on top of. So this is the Kubernetes slide. I'm not going to talk as much. I don't want to go into too much detail about Kubernetes. The cluster's running Kubernetes as its orchestrator. It's a special flavor of Kubernetes from NVIDIA for dealing with GPU workloads and has various nice features like fractional GPU allocation. I've been joking for about 5 years that I've managed to avoid learning about Kubernetes, but this is the year that joke caught up with me. So Kubernetes takes bundles of software and runs them on compute, usually but not always in the cloud. In the context of research computing, you can think of it as doing the same job with which a scheduler like PBS Pro or Slurm does on a traditional HPC. Run AI is a web and command line interface which is meant to abstract away some of the complexity and enable us to work with the cluster without having to become Kubernetes experts. I don't know enough about the details of Kubernetes to go into too many details, but one important difference between Kubernetes and something like Slurm or PBS Pro, Kubernetes was designed to keep huge corporate systems up and running. And part of its design is that if something goes wrong, it really wants to try again, and it wants to try again up to a point. And this graph I screenshotted this the first day we got access to the cluster, and I'd set up a Jupyter notebook. But I didn't understand how entry points worked, and I had given it a non-existent entry point. So Kubernetes started it, then it tried to connect through the entry point that didn't exist, and then it failed. And being Kubernetes went, I'm going to try that again. So I started it again, tried to connect, failed, did that a couple more times, and then gave up. And the reason I screenshotted it was because I felt like I'd leveled up in Kubernetes. I'd had the classic Kubernetes experience of asking it to do something impossible and it doing its best to do it and then failing. So a couple of slides ago, I talked about projects in the Run AI sense. That's this sort of abstraction where it has a group of users and a group of resources and storage that they can use. Projects on the cluster correspond to projects in Dasher, which is the university's research data management and provisioning dashboard. And this is why we've been hassling you to provide us with your Dasher shortcodes. So we're using Dasher as basically the source of truth for who belongs to your research team. When we get a request to use the cluster, we've got a script which creates a whole bunch of those elements that I mentioned a couple of slides ago. So it creates a project on Run AI, it creates a storage volume on the storage, it creates a template for a workload, and then it adds the members of your team based on who it can see in Dasher to the access rules for the cluster. And that means when you visit the cluster, if everything's gone well, it'll ask you to authenticate using Okta, which is the university's single sign-on. And then because Okta knows that you're in a particular Dasher project, it can go, right, you're in this Dasher project. This Dasher project has been allowed to use the cluster. Here's the project on the cluster that you have access to. The permissions for cluster storage are being set up so that they're the same as the permissions for if your project has a volume on RDS. And again, this is meant to make transferring data simpler. I think Tom will talk a little bit more about that in his section. So also, we've been hassling you for cost codes for your projects. So thank you to everyone who's responded to that. Where the normal pricing for the cluster is going to be $5 per GPU hour. At the moment, we're providing projects with 1 GPU month, basically of free credit, which will expire at the end of the year. And I'll just finish up a bit talking about the status of the cluster and the support model. We're still in relatively early days working with the cluster and sorting out its integration with various systems, and having the sorts of teething problems systems like this can have after they're installed. We're also doing some work to improve the stability and reliability of the system as it was supplied to us. Because it's fairly early, we're likely to have outages. We'll be having scheduled outages to do things like upgrade the software and improve the stability and reliability. And we'll make every effort to provide people with advance notice of when these are going to occur. Unfortunately, it's also possible that we'll have unplanned outages. We had an interesting one of those over the weekend. The best way to safeguard against these, particularly if you've got long-running jobs, is to follow the best practices for these kinds of compute workloads, and where possible, save out checkpoints to the project storage. This means that a training run, for example, if it's interrupted, won't need to start from scratch. So this is something which you should be doing anyway, and we'll be encouraging people to do even once the system is stable. There are heaps of reasons why a run can be interrupted, which aren't because of a system outage. You can run out of memory either on CPU or run out of GPU memory. It could hit a bug in your whatever your script is, which doesn't show up in the first 5 minutes of running, but shows up, after a day or after a week. And also Run AI Scheduler encourages you to save checkpoints so that it can move jobs from one GPU to another. So the other thing I wanted to talk about is support. We're in the process of setting up a formal support queue in ServiceNow, and that's not quite ready yet. For the short term, you can get help by sending requests to our contact form. There's a link to this on the slides. We'll be sending the slides around after the training session. So that form sends things to SIH's internal ticketing system so that we can monitor that, and the research compute team can provide you with help. So that's the introduction. Are there any questions before I hand over to Xiaojin? Okay, in that case. Oh, yes.
What's the maximum number of GPU one can access?
So at the moment, the default is going to be set to 2. The reason for that is, so there are legal requirements. It's the best way to phrase this. There are limits on the amount of compute that we can give to a team without asking what countries they're from, because there are certain countries that have sanctions against them. And one of those sanctions is an upper bound on the amount of compute we can give to them. We will be able to negotiate higher rates for GPU, but to get that, we need to balance first of all, we have to find out who's on the team and be assured that they can, given that quantity of GPU and without exposing the university to legal risk. But the other thing we have to take into consideration is what the cluster's usage is looking like. We can't sort of promise people to have 4 8 GPUs if we don't have that much capacity free. So, yes.
If I had a process that is maybe a bit more CPU intensive as opposed to GPU intensive, is there like a separate option that I can use? Or would I still be kind of leaning towards using the cluster?
So that's something to talk about with. So we also run the Sydney scheme, which provides compute on NCI Guardian, and that.
Photonics.
And we've got Pawsey Photonics coming up.
2 national supercomputers.
So if there's the other thing, if there's more CPU than GPU, or you're not willing to wait for GPUs, you might have to on those platforms, then those might be better options.
Also, if you want AMD GPUs, Photonics has more AMD GPUs than anywhere else in the country. So
okay. Are there any questions? Let's see if there's any questions from the chat. If there aren't any more questions, I'll hand over to Charging. Oh, you can talk through the mic here. Okay. Okay.
What? It's still going through the wall.
Yeah, I'm still sharing my screen. That's
Online with the student. People don't just look at your screen.
they're currently looking at your screen because you've managed to share your screen to Zoom. Yeah. Yeah.
Exactly. Oh, right, it's not. Oh, right, it's an interesting database.
Yep.
I want to leave going. Okay, can everyone online see my screen, like the Run AI login page? Yep, thank you, Xinwei. So, hi everyone, my name is Jia Xin. I'm working as a research data scientist at SIH. So in this section, I'm just gonna quickly guide you through how to log into Run AI using your university single sign-on, and then to make sure you are seeing the right project and the right data source. So the process is actually very simple. All you need to do is just to go to gpu.sydney.edu. I will just quickly type the URL in the chat. Sydney.edu.au. What's actually working? Just make sure that if you are working from home or just in general or working off campus, you will need to connect to the VPN to access this front end. And then once you have managed to see this page, all you need to do is just to click continue with SSO. Then you need to do a quick Okta authentication to verify you are indeed the user from University of Sydney. And then if everything is set correctly, you will see this message from the administrator. Just letting you know that we are still in kind of like testing phase, and then we are there are currently some workloads running on our cluster, but that might be suspended because we are reallocating the resources for today's workshop. So if you have seen this page, then you are already logged into the system. So I just pause here to make sure everybody in the room and also the online people can see this page before we proceed.
Yeah, so I think some people won't have their project set up or the users necessarily. If people don't have a project, we need to add them individually as users.
Yep. Probably we can just do it step by step. Let's just see if they can log in first with SSO. If the Okta authentication can pass through, and then later I'll just go through the project and the data source, and then to double check with everybody here if you can see the right information. Okay, we can see some.
Yes, so quite a lot of people don't have a project set up because either we didn't get a project code or
Oh, right.
them, or they don't have a project, we don't have a project code and we have to add them individually.
Okay, I'll just quickly repeat what Ting has said for the benefit of the people online. So you do need to send us the project code to be able to see the landing page, because we have to sort out the access rule in the background.
Right.
So if you haven't done it, please either send through the Zoom chat, or you can email us directly for your dash up project code. And I can see in the back, someone was raising their hand. Do you have a problem?
Okay, thank
Are you okay? Yep, awesome. I think we just use the first 5 minutes to sort out the access issue before we go ahead with any more.
Dasher, we got a Dasher.
Yeah.
Yep. So my colleagues in the room are now helping everybody to get the right access to the cluster. And Mike and Xin will be helping out with all our online attendees. So please reach out to either the people in the room or our online coordinators to make sure you can see the right page.
2848.
And then I think that's
Perfect, that's exactly where you're meant to be.
yeah, RNM should be coming.
We're getting there.
While we are working on resolving the access issue, I will also share our user onboarding guide
Whatever
that has all the information that I have just talked about.
If you're a member of it, then does it have
Give me a second to go to the right page.
Yes, yeah, cool. Just use this for now. It's fine.
Okay.
So you just need the project, the short code. And the downloaders and PLJ's team. And probably just add all these for a project. Just reply to this. Actually, don't do that.
So if you can click the link that I've shared in the chat, that basically tells you how you can log into the cluster, and also how you can verify if you indeed log into the system.
Gosh, that's long. I'm gonna email that to me. Yeah, Thomas. Yeah, just email me your project code. Yes. Okay. Yeah. Okay. Yeah. So what's it answer to? Do you wanna start?
Oh, that will be.
How are you guys going?
Unfortunately, we don't have the code, so we can't like,
Do you have any Dasher project?
no.
Okay, okay, what we can do is add you, we've got a training project that we've set up, so.
Oh, yeah, that's nice, that's nice.
So just give me your.
Unikey, right?
Sort it out, yeah, just write it down.
Yep, Tom, I just repeat what you have just said to that group. So if you don't have any Dasher project, you can also contact our team and we'll be able to assign you to a training project specifically for today's session. But for long-term access to the GPU cluster, we do require a Dasher project code just to provision your project and also to link your account to the right kind of like permission and resources. So please do reach out for anyone online if you run into 4.3 error or you just don't see the right login page.
Yeah, okay. Right.
Andrew, I might just add you to training as well. See, it's fine.
And the project into.
Okay, I think we are almost good to go. Tom and team?
I mean, people will still. It takes a few minutes until I get everyone.
Right, okay, I'll still wait for a couple of minutes.
Hi, so I just sent out my project code and my unit key in a private message. So I'm not sure whether that could be added. Thanks a lot. Yes,
Yep,
it's
that's
me.
you, Ryan.
Thanks.
Yes, I've just emailed that to Tom and Tim.
Yeah, thanks.
Thank you.
Yep, thank you, Iran. Yeah, we are working on resolving your problem.
I mean, I've had a bug that didn't really help.
Just maybe while we are helping everybody to get the right permission, in terms of long-term plan, we hope that we don't need to ask everybody for the short code every single time we need to onboard a new user. So we are still working with the ICT team to streamline the process. So hopefully, fingers crossed, we will be able to get that down. I don't want to give a timeline because all the managers looking at me nervously.
Beginning of next year.
Beginning of next year. Thank you, Gordon. So basically, all you need to do is just click SSO if you have been added to a Dasher project and without emailing us with your shortcode, etc. Alrighty. So I think I'll just quickly talk through what you can see on this page. So basically, the first one I want to talk about is the overview tab, which gives you, as the name suggests, the overview of the cluster. As you can see, we have in total 3 GPU nodes, and each node contains 8 H200 GPUs. So overall, we have 24 GPUs for whoever to use. And you can see, for example, now there are 2 GPUs in use. And there's a bunch of other system charts on this page, but we don't need to go through every single one of them. But basically, this is where you can always go and have a look to see how busy the cluster is, and then also make probably initial judgment. If, let's say, your job is not scheduled, very likely it's because the class is too busy, so you just need to be a bit more patient till there's any free resources available for you to use. And we also have analytics page that is also giving you some insights about the status of the cluster. It can be a bit daunting, I guess, for you first to see it. And so for our team, yeah, if the cluster is busy and we'll be able to use the same page to monitor the system as well. And then, as you can see, there's a gap there. That's because we had some system issue like early this week, but we are very happy that we managed to bring it back so we can run this workshop. And then the next page is project. So as you can see here, I'm part of a project called SIH Next Gen. So in your case, it will be the Dasha shortcode you have provided to us, or the training project we temporarily created for today's session. All you need to do in this page is just confirm. You can see this project code, and we are good to move on.
Let's check as she might think about. You've added these ones. Should do, but not necessarily sure.
Dries, you don't see the two dashboard tabs?
Yeah, I see dashboard.
You don't see dashboard either?
No.
Oh, that's interesting. Because I'm logged in also as a normal user, I don't use my admin account.
And no analytics either, so.
I think I still need to wait for
With the permission.
It could be. I'm not sure, to be honest. Yeah, Dres, and we also confirmed with some of the in-person attendee that you don't see exactly the same page what I'm showing you here. I think we'll try to work it out probably during the morning tea break to see if there's any permission that we haven't really grounded to all attendees. But thank you for raising that. Thank you. Okay, I didn't see any other question related to the project, so I think I can just move on. This workload, my message is pinned here. For the workloads, that's something we will be doing like in this section, which is just to start your first workload. But for now, you won't see any running workload because you have just logged in a few minutes ago. Environment is where you can first configure your own compute environment or use some existing environments to spin up your workload. So we will talk more how to interact with this functionality in Run AI in the practice later. Data sources is a very important component that we want to emphasize here, because as Mike has already explained that we are running everything through Kubernetes and through Run AI. So whenever you start a workload, it's actually running in a containerized environment, and the data in that environment is actually not persistent, which means that if you stop your workload and then restart again, the data will be wiped out. That's why we have configured this data source to store any more permanent information that you want to either copy off the cluster to RDS or to any other clusters you have access to. And at this moment, all you need to check is just you can see this PVC dash. Again, you won't see exactly the same project code as I'm showing here, but it will be PVC dash your Dasha project. If you can see that, we are good to move on. So I just probably wait for again 1 minute to see if any online attendees have trouble seeing this data source in the main page.
I see your name's popped up. Sorry, does it?
It's pretty weird that others are really fucking at the TJ. That's not now.
Okay, I don't see any questions in the chat. I think we are probably good to continue. So we have compute resources. This is basically how many GPUs, for example, you want to request for each workload you are running. There are some pre-configured compute resource option. For example, if you are running GPU only task, for example, doing data transfer, we have already prepared one for you. And there are also some other flavors of the compute resources you can choose. You can indeed define your own compute resource if you have been given the right permission. So you can see this button should be enabled for our users as well. You just click, create a new compute resource, and then follow through the instructions. But we won't actually create one in this session. And also in the demo I'll be giving later on, we'll be using this configured data resource or compute resource. And then I'll just quickly touch on templates and credentials. So to start a workload, there are actually two ways. First is to build everything from scratch, or you can predefine a template which bundles all the, for example, the environment and the compute resource together. We won't actually use a template today, but if you are curious about how you can, once you have already established a more mature workflow, you want to, you don't want every single time you create a workload and you need to click through all the buttons, you can always create a template, just again, for you to, easily start a new workload to kind of like continue work. And credential is where you can store your secrets. If you have, let's say, password or API key or any information you don't want to share to other people, including the sysadmin, you can always create a credential here. Again, that's not something we cover, but it's definitely worthwhile to explore if you do have sensitive information you don't want to share to other people. Alrighty. I can see Xingwei is still busy helping everyone out in sorting out the access issue.
Start a new tab, maybe.
Yeah.
Yes, please do reach out to Xingwei or any team members if you still couldn't see the login page or you don't have the right permissions set, or you can't see, for example, data source or the project listed on the page. Yeah, I think I'll pause probably for another couple of minutes before we actually move to the access.
And those ones.
Still not in there. Can you check?
Yeah, that's good. Alright, so now you're at the next train. Now be a dasher code.
Wait, I said DP. I mean, that was him. Who's RNN?
In the meantime, any questions from our online attendees?
Yes.
Regarding everything I have just explained, or if you still have issues accessing the dashboard, please let us know. We are always here to help.
This former HPC night.
That could be a problem. Simplest thing
You
is
have a dasher.
training. You have to be a member of the group. Yeah. So we're going Nova and
Oh yeah, you've never used it. Alright, so you need to be on a dasher project. So I just used it. So
did you? Oh, sorry.
it's
Different project. TOH.
Oh, QH. Sorry.
Stressful.
Gotcha. Are you Christina by any chance? Okay.
Yeah.
Alright, now you need to. You provide the ticker box to say approve.
Cody, good question. So just for the benefit of the people in the room, Cody's asking, once it's linked to our Dasher, we don't have to manually create projects in here, and it will be automatically set up. So that's correct. That's our long-term plan. So you don't need to go through the hassle of sending us the shortcode anymore. Once that's linked to the university
Yes.
Dasher RDS systems. But now that's unfortunately not ready yet, so that's why we are still doing some manual work to kind of like
Then you'll have
sync it across, basically.
research. I can ask a question.
We're slowly getting people.
It's definitely working.
All right, yeah.
Yeah.
Xinwei, just quickly check with you how many people you are helping to get the access sorted.
I'm going through the list.
Okay, it's still a long list, it sounds like.
If
All right,
if
I'll
miss-
probably wait for another 5 more minutes before we proceed because we don't want everybody to see like 4 or 3 pages and you can't really do the exercise.
And we had a
if
project.
I missed you, can you just send me your staff email again? That would be good. Yeah, I think it's working for most of the people that I've went through.
Yep, process for people that don't even have a Dasher project.
Yeah, so
Test it out.
we're adding them to a training project. Just give us your user. We
Yeah.
will staff an email from that and add.
I think you can send through it.
You just find it out.
Oh, then we'll get you on a training account that you build up the Dasher project and send that through to get access.
Or just move those.
I'll like mute for.
Right. your
Write it down.
Oh, so can
Like
mute
the-
it. It's also using.
What's your unique key?
Wait. No, I'm using Chrome. Use this, but because I don't between.
Okay, I think we are. Hello?
Yeah, that's good.
I think it's still echoing.
Now they can hear you in the Zoom.
Okay, I'll just keep talking.
I mean, Jimmy's might be still.
So everyone in the room.
Kicked me
Oh,
out.
no.
I'm happy to just watch, really, it's okay, don't worry.
Yeah, just to quickly explain why some of the people might have seen a different like landing page. So if you have been added to the training project, we temporarily only give you like a slightly lower privilege to view the system chart because again, it's temporary and then it won't affect anything we will be doing in this workshop. But once you have gone through the, standard onboarding process, sending us the dasher code, and then we'll be able to set you to the right privilege that you can see the system charts here. Alrighty, I think we are all settling down a little bit. I think that's a good sign that we all see the page. So let's continue. So what we are planning to do in the next half an hour is just to show you how you can start a workload and actually spin up a Jupyter lab interface so you can do your coding, data analysis, and or any AI ML workflow you want to run on this cluster. So what you need to do is first to navigate to the workloads tab and then click new workload. And then here you have been presented with several options, and what we'll be using today is workspace. And that, sorry?
Never find that tab.
Yep, just to double check with everybody, both in the room and also online, if you can see, let's go back. So you navigate to the workloads, click new workload, and click workspace. It's a bit a mouthful thing to say, but yeah, that's just the run AI terminology. Workloads and then workspace. And then ideally, you will only be added to one project, in my case, SIH NextGen. Sorry?
I saw a typo on that for that. See the, if you scroll down, you hear that?
That's not a typo.
Oh, yes, that's actually not a typo. Yeah.
I know.
Yeah. So this is a template section that you, as I explained before, if you have already established a more mature workflow that you want to run on Run AI, you can bundle everything together. But in this exercise, we'll only use, we'll just build everything from scratch. And also this GUP is not a typo, it's just a name we have given to this specific environment.
Elsa's all dancing.
Oh, that's.
So they call it short for GPU, I guess.
Yeah, thanks, Tom. Okay, I hope everybody can see this page and can follow along. And then here you need to give your workspace a name. So normally we would encourage people to give it a very descriptive name that you know what this workload is about. So, but in this demo, I just say my Jupyter workload. Hope I don't make typo here.
You're unique, right?
But if they're working in individual project. Oh, but for people sharing the
it's going to pipe up. You're right.
yeah, but for people sharing the training project, yeah, please put your either your initials or your first name, after the workspace name, just to avoid any conflict with other people creating the same workload. Yes, that's something we will get to later. How you can kind of like make a copy of your running workload and then rename it so you have a dev environment to work on. So okay, I think even though I'm only working on this one Dash app project, I will still put my initial here. So, and we'll click continue. Oh, sorry, I should not have selected the template. My apologies. So I will just cancel it and then go to workspace and then select start from scratch. My Jupyter workload and JF. Let's continue. And then today we'll be using one environment that we have already created for this workshop. And you can also use that as a base image to keep building any customized tools for your own research. So this one is called Jupyter Dash Notebook, and it's an image that we have pushed to our SIH Docker Hub. So it's called DGX-Interactive-Jupyter Lab. And I've just noticed that we haven't really shared the onboarding guide for this session. I will just quickly.
Yeah, I can share it
again. Yep, that'll be awesome. Thank you. Again, that onboarding guide has all the steps explained. Alrighty, so move on. So you can see here in the runtime settings, we have already pre-configured a bunch of things. For example, to select the right tool, which is Jupyter Lab. And then there are also some user ID and group ID you have to pass through. That's, again, something we have already pre-configured, so you don't need to worry about in this session. And then in the compute resource section, we will choose small fraction, which will use only 10% of the memory, so that we would have enough resources to run all the jobs concurrently. So please make sure you select small fraction when you navigate to the compute resource selection box. And then at the bottom of this config page, we have volume, data sources in general. The only thing that you need to concern in this section is data source and pick the one that starts with PVC dash followed by your dash shortcode. So that gives you a more permanent place to store your store your research data. But we will still encourage everybody, once you have finished your work on the GPU cluster, please back up your data to your RDS And later, my colleague Tom will demonstrate how you can copy data to and from RDS so you will be able to have the data, the correct data you can feed to your training pipeline or whatever job you want to run on this cluster. Okay, and then all you need to do is just to click Create Workspace, and then you will go through several stages. First, you will be creating the workload, and then you'll be pending for hopefully a short period of time to allocate resources on the cluster. And then hopefully you will change the status, yes, from pending to initializing, and then eventually we will see a green running status after the initialization phase.
Everybody at this point.
Yes, can everyone follow along well, both in the room and also online? If you are stuck or if you don't understand things that we have explained, please just use the chat to let us know. And yeah, either myself or my colleagues here can answer your questions. Okay, now the status has changed to running, which means you can connect to this container and then start doing your work there. So I think I will just go ahead and click connect and then select the tool as Jupyter. And then you will still need to do another single sign-on. Okay, you didn't really ask me to authenticate my account. And then basically in this part, all we want you to achieve is just to see this Jupyter Lab landing page. And if you have managed to see that, well done, you have created your very first workload on a GPU cluster. Or if you don't see it, raise your hand or send a question through our chat. Yeah, we are always happy to help. Is everyone all good? Can you all see the Jupyter Lab page? Awesome. And we did prepare one example notebook under work. So if you just click the work folder, and then there's a PyTorch example, you can just run through all the cells and then just quickly do that. It's really just using some, standard dataset from scikit-learn and then create a neural network and then go through some training just for you to see you can actually run a very basic training task on the GPU. And then, so you should see, for example, in this, in the output of this cell, it says using device CUDA, which means that you are running your job actually on the NVIDIA GPU. And if you haven't used Jupyter before, what I have done just now was just to click the Run tab and then say Run all cells. And hopefully, if we go back to the Run AI page and then click Show Details, and then if we go to Metrics, you will see a very small bump because it's a very small task, but that's a sign that your job actually is using the GPU memory rather than running everything on CPU, which is very, very slow compared to the NVIDIA GPU. Cody is asking if there will be examples showing how to pull data from the RDS data sources. Exactly, we have prepared one tutorial, to explain it, and then our colleague Tom will guide you through how to do that after the morning tea. So I think that's everything I want to share with you guys in this part. And if you, for whatever reason, run into any problem, let us know. And then I think now we can have a short break, Mike, for the morning tea. Yep. And we will come back at maybe 5 to 11. Okay, let's just have a 15-minute break, and then we'll be restarting the workshop at 10:55. Thank you, everyone. And then in the meantime, let us know if you need any help.
Hi, everyone. Welcome back. I hope you enjoyed your morning tea. Can everyone hear me online? Just making sure I'm plugged in correctly. If you can, let me know in the chat. Thank you. Brilliant. So I am going to spend a bit of time talking about data transfer, and if I have time, maybe a little bit of more advanced stuff to do with using the CLI for Run AI, which allows you to do everything at the terminal rather than in a web browser, which I prefer. I just want to start by saying, I think it was mentioned before, but I'll just sort of re-highlight it. We've built this onboarding guide, the Sydney SIH GPU Cluster Onboarding Guide. This is very much a work in progress. We are filling this in as we go. But this, basically, all of the material that I'm covering and Jiaxin covered is in this guide. So you can do this yourself and follow along. So I highly recommend, actually, even now, I'll put the link back in the chat that where's the chat? There we go. I highly recommend you follow along even today using this guide, because that's what I'm going to do. All right, so data transfer. Let me just go to the data transfer page. There we go. So yeah, you've been introduced to the idea of a persistent volume claim, and that you can attach a persistent volume claim to your workflow, workspace. I always get the terminology mixed up. You know what I'm talking about. That persistent volume claim is the only storage that will stay outside of the life of your workflows. So when you're transferring data, that is where you have to put it. Whatever is your /home in your Docker container or your Jupyter Lab session or your terminal or whatever, that is ephemeral. As soon as the Docker container disappears, that disappears. So you have to always make sure that things stay on the persistent volume claim that you have mounted onto your workflow. So just sort of keep that in mind. I know people said they knew about Docker, but it is it's a thing about Docker, is that the containers only live for as long as they live, and everything inside them also goes away. So the way you deal with that is to mount these volume claims. And each of you will have gotten, I think it's about 1 terabyte per project on the claim. And you can open multiple workloads and attach that claim to multiple workloads so that different things can see the same data doing different things. And in fact, in this case, this is a good example of it. You may be running a sort of training workflow like what Jiaxin talked about, but then you might want to also be running a data transfer workflow independently with the persistent volume claim mounted. And so to do that, you don't need all of the resources that you need for training and things like that. So I'll take you through how we have set up a sort of a minimally resourced environment to allow you to do data transfer. Just before I go into what I'm going to show you, I always say this when I talk about this, and I'm sounding like a broken record now, but this is just a stopgap measure. What I'm going to show you is how you do this in a terminal at the command line to get to and from RDS. At the moment, we are awaiting the deployment of something called Globus, which some of you may have heard of. If you haven't, basically, it's going to make all of our lives a hell of a lot easier. ICT are currently in the process of commissioning this. And it will allow you, just using a simple GUI, without having to log into the cluster, to copy data from your laptop, from wherever you want. Globus has this idea of endpoints, and so you basically transfer data from endpoint to endpoint. And we're in the process at the moment, for example, of setting up endpoints on NCI Gardi for University of Sydney researchers. And we're also in the process of setting that up on the GPU cluster. But for now, it doesn't exist. So you are stuck with the command line. And I will show you how to do things, basically, for now, at the command line. So essentially, what I'm going to take you through, it assumes you have already got a project, which I think we've set up. I think that this seemed to work this morning in the end. And that associated with that project, you will have some kind of persistent volume claim. So let's go back into Run AI. Oh gosh, okay. I will go to the data transfer thing. I had this on my laptop screen, but not on your screen, sorry. Okay, so first thing I'll do, I'll go through what we did this morning again. We're going to log into Run AI. We're going to use SSO to do it. And of course, I need my mobile phone. There we go. And so now we're back where we were before. I'll get rid of my filters. I'm in the training group, so I can see all of your guys' training workflows that have been running in the first half of today. Generally, if you had your own project, you wouldn't be able to see projects that you're not a member of. So I can't see any projects for people who have their own project. That's the sort of how the security works on Run AI essentially. Let's set up a data transfer workload. So Jiaxin showed you a proper training GPU workload. I'm going to do something a little bit easier and simpler. Well, it's very similar, if anything. I'm going to go to new workload. I'm going to click on training, if it works. I'm on laptop. There we go. And I'm going to use a template. I've set up a template for data transfer. It makes your life a hell of a lot easier. If you pick the data transfer template, it will pre-fill everything for you with an environment that will work for data transfer and load a Docker container that is set up for this kind of thing. And then I just need to give it a name. So I'll just call mine Tom M Demo. I think, am I in training? I am in training. Okay, I'll do this in training. And then continue. So since I'm using a template, I've already got my environment populated. And you can see all of the important things about the Jupyter Notebook session that I'm going to start up are pre-populated, except for my supplementary groups. This isn't hugely important, but it's a bug in Run AI. So we are basically getting your user IDs and group IDs and supplementary group IDs from your Dasher information that is populating through. That's how we set up projects. So, in future, eventually, you'll be able to click a button on Dasher and go, please sign me into Run AI, and it will populate all of these things so that we know the permissions and usernames that you're meant to have on the persistent volume claims. At the moment, we're doing that by hand, but also in Run AI, there is a bug that when you automatically fill things in, it doesn't populate the supplementary groups for some reason, so you have to click there and back again, and there they are. So that's the group name IDs of all of the Dasher projects that I'm a member of. And you'll see the same for yourself if you when you log in. And essentially these containers that SIH have built have this set up for you so that all of those numbers propagate into the container and the permissions are set up for you, and you don't have to worry about the persistent volume claim not having the correct user IDs and group IDs for your Dasher project. So everything should be straightforward. Then we pick compute resources. So there is a specific data transfer compute resource. Again, if you picked the template, that will be automatically populated. All you need for data transfer is 1 core and 8 gigs of RAM. You probably don't even need that. That's generous, but that's what you can use. It also means that you won't be fighting with other people for compute resources. Most people want the GPUs. So if you just want to do quick copy some data, much easier to just ask for CPU cores. So these compute resources, there are a whole bunch of pre-populated ones here. You can also make your own when you run your own workflows. You can do things like fractional GPU, which is, I think, what you did this morning, or you can ask for no GPU at all. But yeah, generally that's, at the moment, we're only using that kind of compute resource for data transfer. Then, very importantly, you're going to need to mount your PVC, of course, because if you just copy things into a running workflow without a PVC, as soon as that workflow finishes, all of the data will vanish. So when you're doing this data transfer, you always have to put it to a permanent storage location. And in the case of Run AI, that is the PVC that you mount, that you get when you create a new project. So let's create that.
And your workload stops.
Because the Docker container is ephemeral. Because basically when a Docker container is unique per user, and then as soon as it dies, it goes into the ether. So, and all of the file system on the Docker container is part of the container, not part of the outside world. So that's right, that was quick to start. The main reason that was quick to start is that it's only needed CPU. So we can now connect to this workflow, sign in again. And here we are. This is a much more minimal Jupyter Lab session. You'll see things that you might have seen before aren't there. You can still open a terminal, which is important. And for some reason that happened. Always when you demo things. That shouldn't have happened, but we can still go. We can still forge ahead. That's fine. As I was saying before, these containers are meant to be set up so that all of your group IDs and user IDs are pre-populated, but something happened with the container there. It should still work for us. So if I want to see my persistent volume claim, I go cd/scratch. Which is where it's mounted, and all of your persistent volume claims are mounted on the container in /scratch/ project code shortcode. So in this case, I'm in the training project on Dasher, /scratch/training. Jiaxin was in SIH NextGen. His would be /scratch/SIH NextGen. That's a tongue twister. And whatever you guys have, that's what you'll see. So you can CD into there. And have a look at what's going on. So I've already been playing around in this PVC. There's my uni key is in there, but you essentially have complete permissions to go wild. I worry that I don't, because I have this container hasn't started up correctly. Let's just see what happens. Yeah, unfortunately, I'm getting permission denied, which is going to make this not go very well. Hopefully this is better. Oops. Yeah, okay, I can do it in my subdirectory because I've given that directory group access. That's the sort of trick here. Normally when you do this, hopefully for you guys, I'm not sure what I did wrong earlier, but this should be set up so that this just works out of the box. It did for me this morning. I don't know what I've changed. Unfortunately, that's what happens when you do demos. So yeah, so anyway, once you're in, you can look around as if you're on a Linux terminal here and do whatever you want. The easiest way, basically, all I'm going to show you here at this point is the easy way to transfer data to RDS. And from RDS, so we've done all of these things, is to use SFTP. So I don't know how much experience you guys have with this, but yeah, that for now is the best thing we have. You connect to RDS through a portal called Research Data Ext, and that basically contains the entire RDS file system. Again, you can only see your own projects on there. There's a lot of information hopefully linked to here. If not, I will add it at some point about, yeah, it's not linked, but about how to access RDS and how to log into RDS and SCP things or SFTP things. The reason we're using SFTP is unfortunately we can only access research data Ext from the GPU cluster. Not int, even though it's in the university. So yeah, interesting one. We're going to talk to ICT about that. It worked a month ago, but then it stopped working, so we're not sure why. So anyway, so SFTP is the go. And of course, again, I'll reiterate, this is all going to go away once we have Globus. You'll be able to do all of this using Globus once it's connected to the cluster. I'm not sure what the time frames are for that. Mike, do you have a clue? Yeah, okay, next year, if everyone online can hear that. Okay, so I'm just going to cut and paste this command. In fact, I can do it from there into my Jupyter Lab and then fill in the blanks. So SFTP is pretty straightforward if you've used it before. I've never worked out how to get home button working on my Mac, so you have to watch me scroll the cursor all the way back. I've tried everything and it doesn't work. So let's start with, we're logging into Research Data Ext, TMAU0037. That's my uni key. Of course, you'd put your own uni key in there. And then we're copying things from Research Data Ext from /RDS/your project. So in this case, I will go from project, let's do SIH NextGen, SIH NextGen /path to a file or folder. I'll come back to that. And then we just say where we want to put it. And in this case, we will go PVC mount point is /scratch/training. And let's create a path that we want to put it in. Let's just put it here. And actually, no, let's not. Let's just put it here for now. In terms of the path to file or folder, I can't, well, I can because I've written it down, but generally I wouldn't off the top of my head know necessarily what it is in RDS I want to copy. So what I often do is just my little trick is you can log in. You can either mount RDS using the SMB share, which again, go to Confluence and read the instructions on how to do that at the university, or simply open a terminal and log into RDS in a terminal. So I can go SSH TMAU 0037, and here I can use research data int. .sydney.edu.au and password. Hopefully you can't all see that. And then we can cd to /rds and then SIH, project PRJ dash SIH next gen and have a look. So this is our Sydney Informatics Hub toy project where we do a lot of things. I've made a data set here called DGX Workshop. If you're doing this yourself, you won't be able to see this because you can't access our RDS drive. So try copying something from your own drive. That's just try logging in yourself. Oh, didn't mean to do that. And then so we can pick the folder. So we can go, okay, we're in Project SIH Next Gen. I've got this folder called DGX Workshop. DGX Workshop, and we'll put it in /scratch/training. I think that's already there, but let's just do it anyway. Oh, this is a pain. Unfortunately, do you also have that? Yeah, something has happened to this data transfer workflow, unfortunately. Oh, it's a real shame. This worked this morning. I'm going to have to quit out. Sorry.
Yeah.
No, what it is, it's fine. It's getting the UIDs and GIDs. It's that the container that I'm running is not setting itself up correctly to do this. But like I said, I ran it this morning and it worked fine. So, pardon? Yeah, I'm just having a look. Sorry, everyone. So DGX data transfer Jupyter Lab. Don't know if that's changed. Let me just try again. I'm going to do it from scratch. Training. Actually, let's try it from SIH Next Gen, see if that works. I don't want to new it. Sorry. This is always me with run AI, is that I do the wrong thing. It's a workload I want, not an environment. So new workload, workspace. Let me try SIH Next Gen. Let me leave that blank. Let's do that. Start as template from scratch. And then I know what's happened. It's the wrong name. Okay. I think the notebook, I think I renamed it. No, well, the UID DT one used to work, so let's try that. But I definitely did this morning. It's really PVC. Let's try that again. Initializing. Connect. Sorry, guys. That is a damn shame. Tim, have you tried?
Yeah, okay.
You're getting that too. Sorry, everyone.
For the other
Container, yeah. exactly. Good idea. All right, I'm going to quit this one. I'm going to delete that. And I'm going to pick a new workload, workspace, SIH Next Gen. So if I pick this Jupyter Lab environment, yeah, supplementary groups. We only need data transfer. You can just run this Jupyter Lab environment with data transfer. And then Tim and I are both trying at the same time. Okay. Okay, that's much better. Sorry, everyone. But yeah, so if you want to do this, use the Jupyter Lab environment. There's something broken in the data transfer environment that we set up, but it should work from the Jupyter Lab. The environment you were using this morning to do the GPU training, you can do this from there as well. But don't pick the GPU compute resource. You don't need it. You can change to the data transfer compute resource when you start it up. Or if you've still got it running, you can just use it there. The previous environment. Okay.
Or if we don't have it.
No, we should be able to. So if we go, I mean, we don't need to copy the old environment. We can just create a new workload using that environment. So yeah. All right. So now we're inside Scratch. Now I'm in SIH Next Gen. Okay. So back to where I was before. I'm going to copy and paste this SFTP command. And I am going to scroll very slowly again. Does anyone know how to do this on a Mac? Control A. Wow, thank you. Function left. I'll leave it at Control A for now. That worked. So my uni key at research data X, I'm copying from /RDS/ I can still copy from the training project here. In fact, let's stick with SIH Next Gen. That's fine. Sorry. So I'll copy from the SIH Next Gen project and put in the path there that I had open on my terminal earlier, but I have written down so that I don't have to look again. DGX Workshop. And then on here, we will do it to /scratch/ SIH Next Gen, which is the PVC mount point. And let's just put it here. Let's see what happens. So now we are able to connect. Again, it wants my password. I think I just mistyped it. And then it's connecting. I feel like I'm doomed. I literally did this morning. There we go. Yeah, so there's your data copying across onto your PVC. You can neatly in a Jupyter Lab session, you can open another terminal. So while that's running, and I can CD back to my Scratch /SIH Next Gen. And you see it's created this DGX Workshop folder, and it's slowly populating with my data. Yep, there we go. So that's how you copy from RDS to the cluster. To go the other way is in the notes. I've still got quite a bit of time, so we can do this. So now that I have copied my data, and say I've done Control A. Wow, changed my life. And then TMAU 037. And so in this case, we're using SFTP to copy back to research data, but it's basically filling out the same things. So SIH NextGen / path to file or folder. I'll just put it in the SIH NextGen. And then we say we're going to put /scratch /SIH NextGen /DGX workshop /my-data. I'm going to copy my data rather than DGX workshop. Let's see what happens. So again, it asks my password. And there we go. There's one slight caveat with going the other way. SFTP has what some might call a feature that can't be turned off, that it tries to set the permissions of everything that is copied to RDS to the same as the user that is running things here. But of course, RDS won't allow you to change the permissions of things. So at the very end of this, you'll get a permission denied error. It's not actually an error. The data has been copied and the data has the correct permissions on the RDS. It's just RDS telling you that you can't change things there. You have to have a certain user ID in a group. It's an annoying thing that it does. If we were using rsync, it wouldn't have done that. Unfortunately, Research Data X doesn't allow that. Yeah, any questions? Sorry, I've been rambling on. That's where we are with copying data right now. But yeah, watch this space. Next year, Globus will come online and things will be a lot easier.
Globus is also being rolled out before the end of the year. So we're transferring data from RDS to NCI, NCI users. So there's some opportunities to get experience with it before the year.
Can I just point out as well, I've shown you RDS, so you can't go directly to your own laptop from the DGX cluster. You can set up an SSH server on your own laptop and copy to that. But if you're on NCI, you can copy directly to NCI from here as well, which I find quite a bit easier. It's not in the instructions because most people aren't on NCI, but if you have another server somewhere that's external to the university, generally speaking, you can do this. So you can just go rsync, although it might not be in this. Oh, I've got it. Excellent. -AP. Let's see what we can copy. My data, and so I can copy it to my 0464. That's my NCI login at gardi.nci.org.au, and then I'll just put it in my home directory there. So this is now logging into NCI. Put my NCI password in. And that's using rsync to copy somewhere. So, Research Data X can be a bit annoying because it doesn't have SSH access and you can't use things like rsync, which are much easier to use, and do things like checksums on the fly for you. So if you've got a disk space somewhere else that you have SSH access to, you can copy things there as well. And Gardi, I think, is a really good one. I've been using Gardi a lot to copy things to and from the DGX cluster. Again, Globus will solve all of this. I know I sound like a broken record.
Straightforward to transfer from a laptop.
Exactly. Yeah. So you can set up your laptop as an endpoint on Globus, and then you can just copy directly to the DGX from your laptop. It'll make things much easier. And this document, like I said at the beginning, this data transfer or the cluster onboarding guide generally is a living document. We're learning as well. When things change and when things get updated, we will put instructions in here. Generally speaking, I know you had to use the Jupyter Lab environment there. However, these instructions tell you to use the data transfer environment. I will fix that before the end of the day. I don't know what changed, but something went wrong there. But generally speaking, you should try using the data transfer environment because it just pre-populates everything for you, and this is a much more simple container to do the data transfer. Are there any online, on Zoom questions? I haven't really been paying attention.
Okay, to copy data from my laptop to DGX via Hugging Face.
Well, so you could probably access Hugging Face directly from the DGX. You probably don't have to use your laptop as an intermediary there. Sorry?
Laptop Hugging Face DX.
Oh, yes, you can do that. If you have enough storage space on Hugging Face to put things there, you can absolutely, and then use the Hugging Face API to download models as you require. Just remember to save those models on your PVC. If you put them on the internal storage on the container, it will disappear when the container finishes. And that might be fine. You can, in your script, have things upload back to Hugging Face, but just be aware that that's something to look out for.
I think there is, RunAI have an integration.
It does. We haven't explored it. Yeah. Yeah.
It's one of the obvious things for us to get set up.
Yeah.
If we can smooth the path to use
Definitely, yeah. So yeah, I mean, if we, Mike just said that the RunAI has a Hugging Face integration, but we haven't yet explored that. Generally speaking, you can still do it from your own Python scripts via an API, but yes, it is something we should explore and find out more about. And have people.
I'm out.
No, I know nothing about it. What is the idle timeout?
We're going to time out your job if you leave it idle for too long. The resource.
Okay. Does someone else want to speak to that? Because I'm not aware of the discussion here. Get this down. Sorry. There you go. I'll come back and do the CLI if people want.
Yeah, hi. Just wanted to mention that we will be putting a whole bunch of policies in place because the cluster is a limited resource. So we'll be enforcing an idle timeout for jobs that we don't want people parking on GPUs and not using them. We want that to be freed up. This is a problem that a lot of, there was quite a bit of talk about this at eResearch last week about at UQ, their computing environment, Bunya, has a thing called Job Cop, which basically goes around looking for people who are parked on GPUs and not running them and killing them off. Other things to talk about with resource allocation, we want the Scratch storage to be used as Scratch. So it's not meant to be, as I said in my introductory slides, it's not meant to be a permanent home for data. We do, however, know that we don't want everyone to have to copy all of the data across for every job and then copy it back. Obviously, in a lot of use cases, you'll have training data that you want to try different models on. You will be experimenting and trying different approaches. The model we're looking at is one that the national compute platforms have, where we will do basically scan and flag the file system for files that haven't been accessed within a certain amount of time, which will be fairly generous. It'll be something like 30, 60, 90 days. When we detect files like that, we'll then send email notifications saying these files have been flagged, and then there'll be a grace period before we actually delete them. This is what NCI do with their Scratch, because if you don't, you might have been familiar with how Scratch worked on Artemis, which was basically Stephen Coleman sending out polite emails every so often, asking people to clean their stuff up. We don't want to end up in that situation. We want to be able to have automated processes that clean stuff up, but also give researchers a chance to keep stuff alive if they need it to be there. Hand back to
I think we're kind of near the end. Yeah. But I'm happy, if people want, I can show you, there's another way of accessing RunAI through a CLI, it's a command line interface. So I'm happy to just demo that quickly just to show you how it works. Have I still got my workflow running? It's just, yeah, so I'll leave this running. That's useful. And then So yeah, in Run AI, if you don't like this web interface, like me, I can't stand it. You can access your running workflows and even run workflows from a terminal at the command line, much like you can. AWS has a CLI, and many of the cloud providers have CLIs. So you can do all of that kind of stuff with Run AI as well. It's fairly straightforward to set up. I have included an extra page on the onboarding guide on how to do that. Essentially, you go to a secret button in the top right here called Help, and you click on Researcher Command Line Interface, which takes you to a new page. It is only supported on Linux and Mac. If you are on Windows, I guess you've got WSL, but essentially it's Linux or Mac. I'm on a Mac.
One coming in later.
Is that true?
Yes.
Okay.
Yeah.
Okay, right. Very good. I mean, I know ICT are all Windows users, so they might want it. Yeah, exactly. All right, and then it literally just gives you, this is based upon your login, all of this stuff. So you have to do it for yourself. And it gives you a command to copy. You can just copy it to your clipboard and paste it into a terminal. Let me find a terminal. This one might be all right. Actually, I had one in the background. There it is. That command looks like that when you paste it in. That's your authorization key on Run AI. It's basically going to, if you run this, it will ask you a bunch of questions. I'm not going to run it again because I don't know what happens if you've run it once and then you try running it again. I don't want to break my CLI access. I'm pretty sure it'll work, but let's not tempt fate. I've already had one nasty experience today. So run that, and it will ask you a bunch of questions. It'll ask you to authorize with Run AI itself on a web browser, and then it'll say set up. It's a very straightforward process. It's really, the questions are not hard. They're very simple. And then once you've got that, you will have access to the Run AI interface at the command line. So it's basically put things into your path that's set up Run AI as a command line interface. So the first thing you do if you want to use it is go Run AI login. And that will again take you to the web browser where you log in as you normally would. And it will tell you here, it knows that you're coming in through the CLI. It says you're now authenticated and can go back to the CLI. I now have a suite of commands available to me that allow me to do many of the things that you can do in the web interface. Not all, but many. Oh, yes. It's the kind of thing I ask for, and I don't bother to do it for other people. Command Shift 4, yeah? No. Shift plus, maybe, yeah. Command plus. Where's the plus on this keyboard? Oh, look, let me just do it the old-fashioned way. Actually, the newfangled way, really, isn't it? Make text bigger. Yeah, maybe a few times. What is the command for that? Command plus. I just can't find the plus on this keyboard, unfortunately. Oh, there it is. Command. There we go. Is that better? Yeah. I'll do one more just to be sure. Okay, so yeah, now I have available to me a whole suite of commands that work through the command line interface. You can do basic things like log in and log out, which of course we've already done. Most of these things won't be available to you at your access level on Run AI, but the important ones will be. So for example, let's do Run AI project. So these are all the projects I'm a member of. I can tell it even shows you allocations and how much is going on those projects. You actually have to do this to do anything on Run AI. You have to pick a default project that it's set up with so that then all of the subsequent commands will happen under that project. But if you run this, you will only see the projects that are available to you. You'll probably see training and or whatever other project you have. I'll go back to SIH NextGen. So you can see project SIH NextGen set successfully as the default. Then let's run a workflow. So in here, what's the bet this will fail? There we go. We can run a workspace, actually. I'm very bad at the terminology. Control A, hooray. So run AI workspace submit. We give it a name. Tom M CLI demo. We tell it what image we want to run. Again, we have a pre-built image that's just a terminal interface with a whole bunch of things installed in it. So you can use this. This is what the example is. And you'll see when we get in, it's just a simple interface. It has PyTorch, TensorFlow installed, IPython, NumPy, just basic things. You can make your own container as a base container and install your own code in there as well. You can request GPU devices, which I will delete because I don't want to. It'll take too long, and I'm worried about resource allocation. So I'll just ask for one CPU core. Very importantly, you have to include this run as user command. That's how it gets the UIDs and GIDs pulled over, much like you saw in the interface. And I can mount an existing PVC. This is where it often gets difficult, but let's see if we can get it right. So you have to give it your PVC name. In the case of training and SIH Next Gen, oh, I've lost my piece of paper. Or you can just yell it out at me, Tim. That's the one. Yeah, thank you. So the PVC name should generally be the same as what you have in the web interface, but for this project, it's slightly different. It's because we provisioned it. That's fine. exa-pvc/SIH Next Gen. So that's the PVC, and I can say where I want it to mount. So I'm just going to mount it in /scratch. I'm not even going to add the local project name. And attach just means run it in a terminal. If you leave out attach, I don't know how well you guys know Docker, but it would just run the container as if it were a Docker container, and that container would do whatever it does. You wouldn't see what's going on. It will all just happen in the background. But you can then attach to logs and see what's going on inside the container. But for this purpose, we want to do things interactively. So you can just go attach, and it will attach us. So it's creating a new workspace. It's tracking the workload status. What's always fun is that you can see this live in the, there it is. You can see it in the GUI. And it's initializing, and there you go, it's running. It usually says press enter if you don't see a command prompt. There we go. I'm inside a running container in my terminal. This, like I said, we've set this up, it has IPython in it. Your PVC is in /scratch. If you mounted it correctly. You can put your scripts in your PVC and just run them from here. You can, when you attach like this, as soon as you quit out, you're detached. There's nothing you can do about it, but there is a trick. So I will exit out of that running workflow, and I'll just cut and paste the same command. And this is a classic Docker trick. People who are in the know about Docker, this is the kind of thing that you can do, and I've put it in the instructions. Here we go. -- command. This is classic Docker. And so, sorry. It's all right. And then we will go back to here, copy the right text. I see I copied everything but what I wanted. Let's see. And then there we go. It's going to complain because I have already got a workspace called TomM CLI demo. So if I go Control A,
We've changed your life.
it really has. So, yeah, I used to avoid that. You can also do run AI workspace delete. So I could have done delete first of the old one, because even though I Control C'd on the workspace, it didn't kill it. What it did was stop it. And that means it's still sitting on run AI. Run AI still believes it exists. So you have to delete it to free up that name, basically. But let's do that. So now it's running in the background. Now I'm still in my own Max terminal, but this run AI workspace submit is running this bash command in the background. Hopefully we can see it. There we go. So that previous one completed, there's demo 2, and that's running. So that is now running in the background on Run AI. You could imagine this being one of your data transfer workflows or one of your other workflows that you've set up through the GUI. In fact, I could connect to one that I set up through the GUI, but let's just stick with this one for now. It's called TomM CLI Demo 2. So there is a command, Run AI Workspace Bash, that will open a Bash terminal inside any running workspace, even if it's running in the background. So, and you just have to give it the name. TomM CLI Demo 2. Of course, the groups are broken.
This is one of the first things we got asked from one of the very early users is, I've got a
Gotta be able to do that.
how do I SSH to it?
Yeah.
Yeah. You don't need to SSH to it because this gives you basically the same thing.
Yeah, exactly. The group's been broken is work in progress, but essentially it shows you that you can do this. And yeah, and this is running inside a workflow that I'm running in the background. So I could, for example, try that previous JupyterLab notebook workflow that I set up. I think it was TomM test. TomM demo, or there's TomM test, yeah, TomM demo. There we go. This one worked without the permissions screwing up. So now here I am inside the JupyterLab container that I was running before with my PVC attached. And I can do things like look at logs. I could verify the output files, do that kind of stuff as I'm going. And I'll stop. Are there any questions or any comments? Or I think we're sort of we're segueing into a bit of a QA session at this point. So
yeah, there's some permission issues in the chat.
I realized like the Run AI workspace update command, you put the slash square.
Where is that? Yes, that's right, because it has to mount at root. Yeah.
You don't need to do square slash next-gen.
You can make the mount point whatever you want it to be using the CLI. Yes, that's the So when you use the CLI, you don't have to have your PVC mounted at /scratch/SIH next-gen or your project name. You can mount it at whatever name you want. You have a little bit more control when you do that. Yeah. Yeah.
Getting permission denied errors on their system client. So I think it might be connected to the same problem.
Connected to the problem that I had. There's something going on with the containers that I haven't understood. We will investigate that. As you know, it's early days for us as well. So, yeah. Yeah, so we can open it up to any kind of discussion. Mike, do you want to lead the QA discussion? I need a glass of water. No problem.
Yeah, so again, thanks for coming. Thanks for putting up with our technical hiccups and the adventure we had this morning, getting everyone online. As Tom said, it's sort of early days for us with this cluster, and it's early days for the cluster itself. So yeah, are there any questions either in the room or on Zoom? Yep.
So in the existing sort of applications that are available, there's Jupyter Notebooks.
Yeah.
Are there any plans to offer things like our Studio Server?
Yes. Yeah. So we will be building out the standard images that we're providing. I think does that?
That all dancing container that we have has RStudio.
That has RStudio in it. Yeah.
And Python. I recently learned, maybe you all knew this already, that the reason Jupyter is called Jupyter is short for Julia Python R.
Oh, is that where the Duke? Okay. Yeah.
So I have a container that has all of those things.
Yeah. It's also possible to start an environment and pull a container from somewhere, but it's better for us. I mean, people can do that. There's a fair bit of fiddle in getting it working with getting the permissions passing through. So the more that we can do to set that up so that it's reliable, the better. Yeah.
It should have been reliable. Just for some reason.
Yeah. One of the fun things was when we were first playing with it, and I started pulling NVIDIA containers because they've got their own container registry, and half of those were breaking because they're a company that moves at a very fast pace, and not all of their bits work with one another. So, just check the chat. Are there any other questions from Zoom?
On the website mentioned Parabricks for genomics. Is that one of these containers or?
It's definitely one of the things that's on our to-do list. Yeah. Parabricks and Nextflow, because our bioinformatics team are part of bioplatforms and biocommons, and so getting it to be something that you can take an existing Nextflow pipeline and just going, okay, these bits that can utilize the GPU, send them off to the DGX is definitely something on our to-do list. Yeah,
it's proving slightly tricky to go, but
yeah. Okay, if there aren't any more questions, once again, thank you, and we will be in touch with, for those of you who've sent in there who haven't got a dasher, we'll probably send out a reminder email to get short codes and billing information. So, okay, thank you.
Thanks, guys.